Wolfgang Pauli. Wolfgang Pauli was an Austrian, and he did win a Nobel laureate. He immigrated to America in 1940, and yes, he was a part of the Manhattan Project. Pauli came up with an exclusion principle for quantum model. There are three guiding principles when dealing with the quantum model for electron configuration. We will do electron configuration starting very soon, within the week or two. But the three rules are as follows. You have the Aufbau principle. To build up, we always start with hydrogen and build up on our periodic table. The Hund's rule. We fill all orbitals in a suborbital with one electron before filling with a second electron. And Pauli's exclusion principle stated that you must fill with opposite spins. We have a spin up and a spin down. It's a relative term, but basically it's the same idea as magnets, that opposite ones attract one another. So the electron behaves as if it's spinning around an axis, much like our own Earth. And the two directions spin in opposite directions, therefore attracting one another, therefore creating a magnetic field. We use the spin quantum number ms to note the spin. Robert Julius Oppenheimer. He's an American physicist. He was the scientific head of Los Alamos. We call him the father of the atomic bomb. He was a chairman of the U.S. Atomic Energy Authority's on the General Advisory Committee, and he campaigned for international control of the atomic weapons. He did lose his security clearance in 1954. A little more background about Julius Oppenheimer. He noted he figured out as soon as they released their findings about nuclear fission being possible, he had deduced, basically went on the chalkboard and started working on the math, that it was possible. And actually, within a day or so, had drawn up what a possible bomb would look like for this power with the atom. Many people noted him as being brilliant. He also figured out how to make element number 94. Element 94 had characteristics similar to U-235. It consists of 94 protons and 145 neutrons. It is produced by a double beta decay of U-239 after a neutron capture of U-238. He figured out that you could use element 94 in a bomb. So there were two bombs being designed, Fat Man and Little Boy. Fat Man used uranium, Little Boy uses element 94. Also about Robert Oppenheimer, he is the one who chose the location for Los Alamos Project. What you must understand is during this time period, we set up places throughout the Americas at various locations inside what we consider to be a safe zone from attack from Germany and from Japan. And these locations all had backup plans in case one did not come through. So the major construction of the bomb was done in Los Alamos. They constructed basically a whole town in the middle of the night, brought all the scientists in, and got them working on it. Los Alamos is still a current working laboratory. And they detonated the bomb in Trinity Sands, which is White Sands, New Mexico, missile range. And they actually imploded it. It is a controlled implosion that they did above the ground. And they remarked that they thought that it was going to be significant power, but had no idea how significant it was going to be. Anyway, so he's the father of our atomic bomb. He did lose his security clearance in 1954, and that is during the McCarthy time, when basically if someone accused you of being a communist, it was very hard to disprove that you were not a communist. Oppenheimer did have friends who were communists, and that was part of his undoing, unfortunately. But a brilliant scientist. Glenn Seaborg. Glenn Seaborg placed the lanthanide actinide series at the bottom of the table. He is the very last change to our periodic table. Element Sg is in his honor. He also did some work on the Manhattan Project. So if we had not moved those intertransition metals down, this is what your periodic table would look like. Okay? And a few more things about it. Organization. Each element has a box, atomic number, atomic mass, atomic symbol. Your atomic number is the number of protons. It will also be symbolized with a capital letter Z. But generally in this class, we straightforward on the proton number. But please know that proton can be distinguished with a capital letter Z. Your element is identified by the number of protons. It does not matter about the number of neutrons. Neutrons just basically tells you stability. Remember, if you have unequal amounts of neutrons to protons, that element will undergo decay. An element that has equal number of protons and neutrons is a very stable element. Okay. Element symbol, you always capitalize the first letter, lowercase the second letter. Atomic mass unit is the AMU. It's generally the decimal number except for the elements that we have man-made ourselves, also known as synthetic elements. Boxes are arranged in periods, horizontal, and groups vertical. There are 8 main groups. They're designated with the letter A. And then you have your B groups, the transition and intertransition metals. And they fit in between all these.